This is the second lesson in my Full Stack Web Developer Roadmap series. If you don't know what this is, check out this video up here, and I'll also leave a link in the description for you to get an overview of this series. Essentially, this series will take you from having never written a line of code to writing your first full stack web app and deploying it to the web. If you're new here, I'm Zach. I do a lot of full stack web development and other tech tutorials. So be sure to hit the subscribe button if you haven't already and you enjoy this video. Today we're going to be talking about what is JavaScript and why do we use it. Let's see what Wikipedia has to say because we know that's going to be simple. JavaScript, often abbreviated as JS, is a programming language that conforms, and I think I'm going to stop right there because this is not a useful definition, especially for most people watching this. What you can remember JavaScript as is just a programming language. And more specifically, it's a programming language that is made for the web. You have other languages like C++, Python, PHP, Ruby, C#, all of these different languages, and they all kind of have their unique characteristics. And JavaScript's unique characteristic is that unlike these other languages that cannot run in a web browser, JavaScript can. This has been the case for quite some time, but recently, as you can see, the 1.0 version of WebAssembly has been released in 4 different browsers, which does let you write all of these other programming languages to run within the browser. But for now, just think of JavaScript as the programming language of the web because it's the easiest to write in the browser, and even with WebAssembly, there's a lot of complicated steps to get all of that set up. So you say JavaScript is the programming language of the web, but is that all it can do? Well, the answer is no, but if you asked that question 20 years ago, you might have been laughed at. Since that time though, JavaScript has gained a lot of traction in development communities and was the most used language in the Stack Overflow Developer Survey of 2020. And to name a few things that you can do with JavaScript, let's pull this up here. You can create web applications. So there's lots of front-end frameworks like Angular here. You've also got React. I think this is the most popular one at the moment. You can do back-end pieces of your web application or back-end servers with things like Nest.js. You can also create desktop applications. If I pull up my Visual Studio Code, which is a code editor, this is actually a desktop application that was built using this tool called, or framework called Electron. So you can build desktop applications for various operating systems. You can also create mobile apps with React Native and NativeScript. And then finally, you can do AI and machine learning data science projects with TensorFlow.js and a couple other libraries. So to say that JavaScript is not a powerful language is a bit of a miss here because JavaScript has many different applications. The next question that you might ask is, can JavaScript get you a job? And the answer to that is a resounding yes. But JavaScript alone is not going to do it. You have to actually learn frameworks such as the ones that I've gone through here, Angular, React, Nest.js, Electron, React Native. All of these frameworks that are built around JavaScript are what you get hired for. And speaking of frameworks, what is a JavaScript framework, or any framework for that matter? Well, the way that I think about it is the framework is something on top of a programming language, so it's an abstraction on top of JavaScript that enables a developer to do something more efficiently in less time. Facebook is created largely with a framework, a front-end framework called React, and this is a very popular framework. We just went over it. And Facebook could definitely have been built without a framework. It could be built in just JavaScript, HTML, and CSS. But the reason that it wasn't is because the developers there decided, hey, this is getting really repetitive, and we have certain things that we do over and over and over again that we want to kind of automate. And therefore, React was born. React is something that the developers at Facebook kind of created in order to make their jobs easier and more efficient. We can use a little bit of a construction analogy to think about frameworks. If you're trying to build some commercial real estate building, are you going to use a shovel and a ladder to create this whole entire building and, drive all the materials back and forth in pickup trucks? The answer is no. you're going to get huge trucks, you're going to get bulldozers, you're going to get cranes, you're going to get all sorts of big materials in order to build this huge building. And it's the same thing with building web apps, or honestly anything that you would build with code. If you're trying to do it with just a language like JavaScript, and you're not using some of the popular frameworks that have been built on top of that, you're basically showing up to a construction site with a shovel and a pickup truck. So you don't want to do that. In order to be employable, you need to understand how to use these different frameworks like Angular or React, or even a framework like Electron, which enables you to write desktop applications like Visual Studio Code. All right, I think that's enough on frameworks for now. Could do a whole video on it. Let's go to the next question, which is JavaScript the same as Java, or at least similar? And the answer to that is no. If you search enough on the internet, you'll probably stumble upon the analogy of a car versus a carpet. They both have car within the word, but they're nothing alike. And that's kind of the story with JavaScript and Java. Now, Java was actually the inspiration for JavaScript way back in the day, and JavaScript was meant to be a companion to Java. So they do have some similarity, but when you're writing each of the languages, they could not be more different. The next question is JavaScript better than Python, or honestly, insert any language there? The answer to that is always going to be, it depends. And the reason that I say that is because all these different languages that you're choosing between have different unique use cases. And while they can all kind of do the same thing, they all are programming languages, some of them are better for certain types of industries than others. So if you're asking me to build an app like Facebook, I'm probably going to go with JavaScript and use some JavaScript frameworks because that's what those are made for. They're made for creating apps like Facebook. But if you wanted me to do some machine learning and build out the computer that sits in a Tesla, I'm probably not going to use JavaScript. I'm probably going to use Python because Python has a much more mature ecosystem around this topic of machine learning, AI, data science, all that kind of stuff. So when you're asking whether you should go with JavaScript or another language, it really depends on what kind of industry you're getting in, what you're trying to build, all that kind of stuff. If you're trying to build a web app like Facebook, JavaScript is great. If you're trying to do some machine learning, Python is great. If you're trying to create an extremely efficient, we'll say, banking application or something like that, a language like C++, which is much faster in execution than a JavaScript, would be a good choice. There's no right answer here, but there are different ecosystems around each of these languages, and you'll kind of notice as you study them that certain types of developers kind of gravitate towards different languages. Another question that you might have is HTML and CSS required to work with JavaScript? And the answer to that is yes and no. It kind of depends on where you're actually running that JavaScript. Now let's start with the front end because this is a little bit easier to explain, and then we'll move on to the back end. If you don't know the difference between those, I actually made a video on the difference between front end and back end development. Anyways, let's go over to my browser here. On the left side of my screen, I have an HTML file that is actually open in Notepad here on the right. Not doing any fancy editors here, just want to get a few points across. So let's create a basic HTML document here. I know I haven't actually gone through how this all works yet, but we will get there, I promise, at some point here. In the body of the HTML, I'm just going to create a button that says click me. So when we refresh the page, we should see all of this reflected on our web page. And you see that we have a very unstyled button, which is just click me. So this is a example of a web page. This is no different than the home page of Facebook, except for the fact that it is not including both CSS and JavaScript. So this is HTML alone. Now, if we add CSS to the picture, we're actually going to be able to style this. Now we can add some styles to this button. So let's do that right now. We'll add a background color of transparent. And then I want to say the border is going to be 1 pixel, solid navy. Then I want to add some padding to it. So we'll say 20px. We want the font size to be 1.4 rem, just somewhere in that range. And let's go ahead and close that bracket off, save it, and refresh the page. You can see that we have a much better styled button here. We can also add some hover styles to it. So let's go down here and say button hover. And now I want the background color to be navy. And I want the, the border to be none. I want the color of the text to be white so that it stands out on that navy background. Save this, refresh, and you can see that we have a styled button that changes styles when we hover over it. So this is the power of CSS. But if I click this button, it's not going to do anything. It does nothing. It's just a static element on the page, and while it looks like it's changing, looks like it's doing something, that's only being done with CSS and HTML. Now, in many web applications, you have various buttons and forms that users can click on in order to do things within the app. So I'm sure you've been to a login page before where you enter your email and your password and you press login. Well, that is actually being triggered by JavaScript. And while you do need the HTML and preferably CSS if you want a web app that people are going to visually like, you need JavaScript to actually react to different interactions on the page by the user. If you just have HTML and CSS, your login form is going to not do anything and you're going to have a useless app. To kind of give you an idea what I mean, obviously this is not realistic, but I added some JavaScript to this HTML document that also has CSS, and you can now see that every time I click on this button, it's going to add an element to the page. So I'll click it, and you can see that I'm adding a p tag with the text "click to the button" every time I click it. And this is just to demonstrate how once you add JavaScript to your HTML and CSS, you can actually interact with the page rather than just looking at a static website. Well, in this case, all I did was add some stupid text to the page. You can see that how every time we click the button, we can fire an event and maybe send in the login credentials to our backend server, authenticate, get the response back, and then redirect that user to a different page of our site. When we're working with JavaScript on the front end or in the browser, HTML and CSS are pretty much required for JavaScript to run. Now, yes, it could run without them, but it would be completely useless. You'd just be running it in the console like we did in the previous lesson. So it has to have something to actually interact with. Now, on the back end, since JavaScript is both a front-end and back-end language, we can actually run JavaScript without any HTML and CSS, and it can be extremely useful. When we're working with JavaScript in the browser, HTML and CSS are required to make this JavaScript do anything useful, because ultimately the JavaScript in the browser is all about taking those HTML elements and modifying them and interacting with backend data, all that kind of stuff. So HTML and CSS are required in the front end. On the back end, if we're using the Node.js runtime, which is the way that we can run backend JavaScript, we don't need HTML and CSS. Let's write a simple Node.js program to demonstrate that we don't need HTML and CSS. In order to do that, once again, we have not covered this in this series yet, so bear with me. But we need to create a sample.js file. And then we'll open this up with Vim, which is going to allow us to edit this. So once we have this, again, haven't covered this either, but we can make a do math function, something like that, where we can enter in two values and get some result. So let's do a multiplication problem. So we'll just we'll say return x times y and close the braces. And then in order to actually run this program, we are going to actually store it in a result variable. So do math, and we'll say 5 and 80, something like that, big enough where we can't necessarily do it in our head. We'll do like 87 or something. And so it's going to store that in the result, and then we want to print the result to the console. So from there, we can save and quit, and then we can clear the console and run this sample.js program, and you'll see that it did that multiplication for us. So obviously this is very useless and you wouldn't ever do such a simple function, but think about back when we were working on the front end and when we clicked that button. So let's say that it was a register form, you add your email and your password, you click the button, the JavaScript in the front end is going to say, okay, the button was clicked, I need to do something. And so what it's going to do is grab all that data, the email and password, it's going to send it over to your backend server, and your backend server is going to run the Node.js, version of JavaScript, and it's going to say, okay, I got an email and a password, let me look up this email in the database, hash the password and compare the hashed password to the one within the database. And then I'm going to send some data back to the front end in order to tell it whether the user has successfully authenticated. So you can see how these different sides of JavaScript work in different ways, but the point is, no, you don't need HTML and CSS on the back end, but yes, you need it on the front end. And the last question that I'm going to cover is, what is the difference between something like ES5 or ES6 and JavaScript? Well, there's actually an organization called ECMA International, not even sure if I said that right, but this is just a standards organization. And in order to really visualize this, I want to go into a quick example of something that's not related to JavaScript. Well, not entirely. And that is the ISO 8601 date standard. So we're going to go through this example, and then I think everything else is going to make a little bit more sense. So if I open up the console like we did in the first lesson of this series, and I run, let me save a date into a date variable, and then I want to print this date as an ISO string. And you can see that I have this uniquely formatted date, and it looks very standardized, and that's because it is. And it's actually standardized by this, organization called ISO, which is, I think, the International Standards Organization. And there's actually organizations like this across the world for various, different standardized things. And the same thing applies for JavaScript, and that is where ECMA International and the ECMAScript specification, or in other words, you might hear this as ES5 or ES6, all different versions of this spec, this is where these have originated. And so JavaScript is actually an implementation of this specification. And the reason this is so important is because of browser compatibility, among other things. So if you go to this MDN Web Docs article, you can see a grid of all the JavaScript APIs that are supported within different browsers. And the reason that this ECMA standards is so important is because the specification just needs to be updated and maintained in one place, and then all of the different browser developers, you've got different teams for each of these different browsers, they can look at that specification and implement their browser knowing that all of these specifications are not going to just randomly change when, say someone working on the JavaScript language decides that they want, a new API feature. So just remember, JavaScript is an implementation of the ES6 or ES5 or whatever version you're working with. It's an implementation of that specification. All right, I think that does it for this first rapid fire Q&A session that was not very rapid fire whatsoever. But this last part of the video is totally optional. It's for the people who really want to learn the ins and outs of web development and want to continue on with this series here. And what we're going to be talking about in the last part of the video is just the question of, what is a programming language? So we talked about how JavaScript is a programming language, and it's kind of unique because it can run on the back end and the front end in a browser. But we didn't really cover what is a programming language. And I think that this is a very important question to ask, because if you're going to be writing a lot of code, you probably should understand what's happening behind the scenes, at least at a high level. So for this last part, what we're going to call a programming language is a group of tokens or symbols that, when combined together in a very, very specific way, can be translated by something called a compiler into machine code, or ones and zeros that all computers know how to run. You can think about it like this. Let's take a spoken language, something that I don't know, which is pretty much every language except for English, but we'll call it, I don't know, something like Portuguese. If you started speaking Portuguese to me, my brain would not be able to comprehend what those words and symbols and expressions actually mean semantically. Although I can't understand Portuguese, what I can understand is the body language of someone speaking it. So if you've got someone speaking Portuguese and they have a very, sad demeanor to them, I can understand generally that what they're saying is not a happy thing. And it's the same thing with computers. Well, a computer cannot understand JavaScript, it cannot understand Python, it cannot understand C++. It can't understand any of these languages. But if we use something called a compiler, which is just another program, more code that actually reads other code and compiles it down into ones and zeros that a computer can actually understand. So it's taking a language and it's compiling it down into ones and zeros, or we can think of them as body language, because all computers understand ones and zeros. Now, this is where it gets really complex, and I'm not going to actually dive into it during this video. Once we start talking about compilers, then we have to get into the topic of operating system theory and what is our target runtime that we're dealing with, like where are we actually executing these ones and zeros, because each computer is going to have a slightly different CPU, slightly different ALU or arithmetic logical unit. All of these things matter when we're compiling code down. And for each different language and kind of each different operating system, you have to have slightly different compilers and other tools that I'm not mentioning here in order to do that. Now, if you're someone who really wants to understand this in a great level of detail, something that was very important to me, then I recommend reading this book right here, which is The Elements of Computing Systems. And you'll see within this book, I'll see if I can show like a little page here, but we actually get into things like the arithmetic logical unit and how these ones and zeros are actually translated into commands for the computer. Now, I will say, if you're going to read that book, I will warn you right now, it's going to take you months, and it's very difficult to get through. That said, I came out of it learning in a ton, and I was really happy with what I learned from that book. But if you're trying to get a job quickly, you're trying to become employable as fast as possible, do not read that book. It's going to take you too long. It's going to distract you from actually writing web applications. Now, if you're someone who wants to understand this stuff but doesn't have time to build a computer from scratch, which is what you'll do in that book, I recommend a book called Code by Charles Petzold. And this is going to give you all that information. It's going to teach you the ones and zeros, compiling, all that kind of stuff. But it's going to do it a little bit quicker, and you're not going to be quite as hands-on with it. And the final question of this video is, where does JavaScript actually run? And the answer to that is very similar to the question that I asked earlier, which is HTML and CSS required to run JavaScript? And I said, well, it depends whether you're running it in the front end or the back end. And what we're asking here is, where does JavaScript run? And this is where we get into the topic of something called a runtime. And a runtime is basically an environment where code is run, and it gets into those topics that we just talked about with compilers and how do we target different platforms and compile down to ones and zeros. And there's actually two runtimes for JavaScript, and that would be the Node.js runtime and then the browser runtime. And believe it or not, the browser runtime within Google Chrome uses something called the V8 engine. And this is going to actually do all of that compilation that I was talking about. And it's going to get into a bunch of other stuff, some optimization using the just-in-time compilation method, all that kind of stuff. It's going to basically take your JavaScript code and convert it to something the computer can read. And Node.js, which is kind of the back-end version of JavaScript, or the runtime that we're going to use for our back-end JavaScript servers and stuff like that, that also uses the V8 engine, which is similar to Chrome. So you can kind of guess that the creators of Node.js and the creators of the V8 engine that runs in Chrome and Node.js have kind of become good friends here over the last couple years. But this is not the only way that we can run JavaScript. You have Node.js, which is the most popular way to run JavaScript on the back end, and Google Chrome, which is one of the most popular browsers. But in this course, we're using Firefox as our web browser because I think the developer tools are a little bit better there. And with Firefox, we're not actually using the V8 engine in order to compile the JavaScript down. We're using something called SpiderMonkey, which is the original engine for JavaScript that was built within the Netscape browser way back in the day. And as a side note, if you really want an interesting podcast to listen to, look up Browser Wars. I think it's by the podcast called Business Wars. And it's a really cool story about Netscape and how all these browsers gained market share. Really worth checking out, in my opinion. So in summary, JavaScript can be run on the back end or the front end. And if it's run on the back end in Node.js, it's being compiled down using the V8 engine. If it's running on the front within Google Chrome, it's also using the V8. If it's running in Firefox, it's using SpiderMonkey. If it's running in Safari, it's using some other compilation method that I can't think of off the top of my head. But ultimately, these are all different runtimes, and you do have to be aware of where you're running your JavaScript code because it's going to run differently. There are things that you cannot run within the Node.js runtime. If I tried to, let's say, open up the Node.js runtime here, all I have to do is type node and it'll bring me into the console. If I tried to say document.query selector and then grab the body tag of the HTML and I press enter, it's going to say uncaught reference error, document is not defined. And that is because in the Node.js runtime, the document object model does not exist like it does in the browser. So you have to be aware of these different runtimes and understand that certain types of code can run in the different runtimes. It's all JavaScript, but you kind of get what I'm saying here. And at this point, per usual, I've droned on way too long, longer than I ever thought that I would. But you have reached the end of the second lesson of my Full Stack Web Developer Roadmap series. And while we haven't written any JavaScript yet, well, I guess we did in the first lesson, but we haven't actually learned JavaScript yet, we do have a lot of context around it now, which was the purpose of this video. I really wanted to put this video together in order to give you that context so that when we start getting into the details, variables and data structures and functions and loops, all that kind of stuff, you have a little bit of a background to understand it from. If you liked this video, please give it a thumbs up and subscribe to the channel if you want to follow along with this series and series in the future. And with that, hope you enjoyed the video and I'll see you in the next lesson.